Hi everyone. This video is just going to introduce you to oxidation reduction reactions, or we call them for short often redox reactions. You take the RED from reduction and the OX from oxidation and you get redox. And in redox reactions, electrons are transferred from one reactant to another. Reduction is the gain of electrons. So that would be when a reactant gained electrons. When a reactant loses electrons, that's oxidation. And there's a couple of different ways that you can remember this. You can remember the trick oil rig, where oil stands for oxidation is loss of electrons. And then RIG means reduction is the gain of electrons. So oxidation is loss, reduction is gain. Another little trick that some students use is Leo the lion says grr. And this stands for loss of electrons is oxidation, and GR stands for gain of electrons is reduction. So with that very brief background, let's take a look at some redox reactions. And let's take a look at this first one. Looking at this solid copper, what's the charge here? Well, there is no charge, so I would call that 0. And now looking at this copper 2 ion, clearly you can see the charge on the product side is a +2. So what happened to copper as it went from 0 on the reactants to a +2 on the products? In order to change from a charge of 0 to a charge of +2, wouldn't it have to lose electrons? This is an example of oxidation. So this copper lost electrons, and where do you think those electrons went? They probably went to this silver ion. So on the reactants, you can see that silver has a +1 charge. On the products, it has no charge. So what happened to silver as it went from reactant to products, as it went from a +1 to a 0? That's the gain of electrons. And again, those electrons came from copper, and this would be reduction. Again, oxidation is loss of electrons, reduction is gain, and a redox reaction is reaction in which electrons are transferred from one reactant, in this case copper, to another reactant, in this case the silver ion. Let's see if we can do this next one. So what's the charge on cadmium here? Nothing. And what is it on the product side? It's a +2. So again, going from a 0 to a +2 is the loss of electrons, which again would be oxidation. And where did those electrons go? Well, this tin 4 probably gained them. So let's just confirm that. On the reactants, we see the charge on tin is a +4. On the products, we see it's a +2. Changing from a +4 to a +2, yes, that is the gain of electrons. That would be a reduction. Again, in this redox reaction, the electrons were transferred from cadmium, which lost them, to this tin-4 ion, which gained them. Now, I'm calling these examples simple because the charges on all of these ions are pretty obvious. They're obvious or maybe apparent. But that's not always the case. Take a look at this one. So there's a lot to look at here. And if you're not 21 yet, you may not know that this is the formula for ethanol, which is found in beer and wine. And when ethanol reacts with dichromate, well, this dichromate ion is orange in solution. It gets converted into chromium-3, which is green in solution. So this is called the breathalyzer reaction because if you have been drinking and you breathe into a solution or exhale into a solution of dichromate, it'll change color from orange to green. But can you tell where the oxidation and reduction occurred? I don't know. I mean, this chromium on the products is obviously a +3, but when I look at the reactants, it's not so obvious what the charge is here. What is the charge here in chromium? It's not so obvious this time. In order to answer this question, we need to know the oxidation numbers of each element in a compound. And the oxidation number is simply the theoretical charge of an element in a compound. So there are certain rules that we follow to determine oxidation numbers, but I think I'll share those with you in a separate video. That's all for now. Thanks for listening and good luck.